Yes, sir.
Sure.
Yes,
Right.
sir.
Right. So what I'll be doing is I'll be toggling my screen between the notes as well as between this PPTs. Now try to understand now. Last class I shown certain videos. I told that what is the importance of this clutch. Okay, I have given a brief introduction. If students who has not attended the last class, not an issue. I'll try to share the links of the video, or you can see my session of last class, which I have already shared in WhatsApp group. Now, what exactly is this clutch? The clutch is trying to connect the flywheel to the transmission system. So it is something like this. The I want the power. Power is generated inside the engine. The power has to be transmitted to the rear wheels. How exactly the power will be transmitted? What exactly happens? The flywheel will be mounted on the camshaft. There will be a camshaft here. The flywheel will be mounted on the camshaft. Now, so onto the flywheel, there will be, this is a clutch plate assembly case. The one which you see is clutch plate assembly. So this clutch plate assembly will be connected to this. Now, next to the clutch plate assembly, there will be something called as transmission shaft. So it is the interface between, I can say that it is the interface between the engine and the transmission system. Why exactly we use it? To engage or disengage the transmission system, engine. That is what exactly we try to do is, because while changing the gears, it is very much required. How the torque transmitted. So what is the basic requirement of a clutch? When it is engaging, it need to ensure that the torque, whatever the torque generated by the engine, it should transmit the same torque. It should not reduce the torque. So if torque is reducing, then engine power is wasted. So what exactly happens is the clutch, whatever the power generated by the engine, it should exactly transmit the same power to the transmission shaft or indirectly the entire wheels. Okay, without any loss. Obviously, there will be some very minute amount of loss will be there. So let me see what are the different parts is. Okay, one is the basic parts of this is one, as usual I have shown here, the flywheel. Okay, now once the friction plate is connected, where exactly this flywheel connected? This flywheel, to the flywheel, the friction plate will be connected. Try to see it. To the flywheel which is connected, the friction plate. Now the friction plate has certain things called as coil springs. Now why exactly this coil springs? When it is rotating, so when it rotates here, some of this entire coil spring will get compressed. The coil spring gets compressed here. Once the coil spring gets compressed, okay, now without any losses, exact damping, without any vibration shocks, it will try to transmit the power. That is one of the reasons why coil springs are mounted. Now this friction plate, on the other side of the friction plate, there will be something called as pressure plate. If you see here, there is a pressure plate. Now this pressure plate, what we do with this pressure plate is, this pressure plate will be applying a pressure onto this entire friction line, so that if I apply certain pressure force, try to understand it guys. So the name is pressure plate, but exactly it is applying the axial load. Try to understand, this is applying axial load. So this axial load is applied. Now this, because of this pressure plate, the entire disc, the friction plate will be attached to the entire flywheel. This is what the concept happens. So entire friction plate will be attached to the flywheel. Because of friction, there will be a motion. Okay. Now, what to disengage it? To disengage, there is something called as diaphragm spring. There will be something called as diaphragm spring, and there is something called as bearing here. There will be a bearing. This is called as a bearing. Okay. Now, what exactly happens here? To disengage, during disengage, whenever you press the pedal, this bearing will be activated. This bearing will push. The bearing will push the spring. The bearing will be pushing the spring. Now this bearing, okay. Now what this bearing will do it? This spring, whenever it is activated, it will bring this entire clutch plate back. That is how exactly the disengagement will happen. So basically the different parts. Once again I explain. I'll try to show the video also what exactly happens. Engagement, disengagement. You need to understand the basic parts. Basic parts of the clutch plate is mainly the friction plate. Okay, there is coil springs, diaphragm spring, the pressure plate, and bearings. So this is what exactly we call it as. So the construction, when it comes to the construction, the friction plate is attached to the flywheel. Now the friction, the pressure, the load on the friction plate is given with the help of pressure plate. The diaphragm spring is used for engagement and disengagement of this entire clutch plate. This is the concept exactly which you need to understand. Now try to see this video, how exactly this entire clutch will work. Now here, this is the flywheel. What you see here, this is the flywheel. Okay. Now this, we have a pressure plate. If you observe here, can you see this is the cone shape? The cone shape plate which you see here, this is the pressure plate. This is the pressure plate. You have a pressure plate. Okay. Now whenever you press this clutch pedal in a car, now this is what exactly the clutch pedal, when you apply it, what happens, there will be axial force which will be applied here. This axial force we call as FA. This axial force we call as FA. Because of this axial force, there will be a pressure developed. Now the pressure developed on the, see this part, the small part which you see here, right? This part here, this is called as a friction plate. This is a friction plate. Okay, friction plate here. So this is a friction plate. Now here what happens is, because of FA, there will be pressure on this. So axial pressure, try to understand this. Because of FA, the load FA is applied by us. Keep that in mind. FA is during disengagement. When I press, by default what happens is there will be engagement will be there. The clutch will be, by default it will be pressed again as a flywheel. When you press this clutch pedal, okay, there will be a disengagement. When you press this clutch pedal, there will be disengagement. When you are pressing it, what exactly happens? There is a pressure. Whenever you apply the load, there is a pressure here. The pressure is through this flywheels. The pressure applied will be through the flywheels. Okay, that is what exactly the pressure happens in this case. Pressure will be through the flywheels, which you can see here. Okay, so what exactly happens? Now try to see this motion. Now when we are trying to apply a pressure, the force, see what happens to this diaphragm spring. See what is happening with the diaphragm spring. Okay, the diaphragm spring is pushing this pressure plate back. So this diaphragm spring is pushing this pressure plate backwards. So when there is a backwards, if you can observe here, there will be a gap which is formed. This gap means that there is a disengagement. There is a totally disengagement in this particular flywheel. Is it clear? So disengagement between the flywheel as well as the clutch plate. This is the entire concept of this clutch plate, guys. So once again, basically, if I try to write it here, try to see the screen, the main parts which I am trying to talk about. The parts which I am trying to talk about, basically the friction lining, or we call it as friction plate. The friction lining as well as the friction plate which we talk about. The second one, pressure plate. The pressure plate comes with diaphragm spring. Pressure plate comes with diaphragm spring. This friction plate comes with you have coil spring. Okay, the friction plate comes with coil spring. These are the different parts of the clutch case. And basically, so what exactly, which one we are going to design? That is what we need to understand. Now, this subject obviously design of machine elements, or I can say the design of power transmission elements. Which one are we going to design? Try to see here now. Which one we are going to design? We are going to design only this part. Friction. What is this called as? Can anyone tell me now? Which you see on the screen? What is a part of this clutch? Which part of this clutch is this?
Friction plate.
Right. So in entire design, you don't believe, guys, obviously you have so many parts, but in design we will be trying to design. Our design is basically finding the dimensions. So we are finding the dimensions of friction plate only, nothing else. Very simple. Your design becomes so simple. At the end of the day, what exactly you are going to find? The dimensions of this part. D1, you will be finding the internal diameter of the friction plate. You will be finding the external diameter of the friction plate, and you will be finding H, the thickness of the friction plate. That is your design. If you can find the values of D1, D2 and H, that is enough. To find this, we have so much of inputs. What are the different inputs you have here? You have something called as F. What is F? The axial load which you are going to apply. The axial load which we are going to apply, or by default it will be there. During disengagement, obviously during engagement, by default some force will have been applied using pressure plate. Now, What else we need? The pressure. Pressure is from where? Pressure is applied from the flywheel. When you are applying friction, force from one side, the flywheel will be as the reaction. There will be a flywheel which will be pushing back. So this is the pressure which will be there. So this is a few things which you need to understand. The other thing, coefficient of friction, most important guys, the friction between this entire clutch plate or friction material and the flywheel. So there are certain inputs which we use, and entirely we are going to design the entire friction plate only. So basically try to understand. So once again I come back. When I am talking about the design of clutch means we are trying to find friction plate. This is what exactly we are going to design. So when I say friction plate, what are the different dimensions you are going to find? You will be finding D1, internal diameter, D2 and H. H is the thickness. You will be finding this thickness. So D1, D2 and H will be finding it. Now other dimensions will follow. I will be trying to talk about the other dimensions, also very basic dimensions which we will be trying to talk about. Okay. So initially I am trying to talk about single plate clutch. At this point of time I am trying to talk about single plate clutch. Now what do you mean by single plate? It has only one frictional plate. So obviously here, so I have only one frictional plate. On the other side of the frictional plate we have flywheel. I have a flywheel here. So I have a flywheel, I have a friction plate. Now the other side I have a pressure plate. I have a pressure plate which I am going to apply. So try to understand, I have only one frictional plate. Friction plate. So this concept is called as single plate clutch. So sometimes the other name it is also called as disc clutch. The other name it is also called as disc clutch. So we are trying to design disc clutch case. So disc clutch or single plate clutch. So any questions at this point of time? Anything you would like to you want me to answer it? Any questions? So once again I repeat, the design, when you are trying to talk about the design guys, main parts I am trying to talk about, there is something called as a friction lining or friction plate. You have something called as pressure plate. Now you have springs. And one more important part guys, one more important point, there is something like your shaft is also one of the part. Try to understand here. The other part when I am trying to talk about here, plus you have a shaft, because the entire spring is, entire clutch is mounted on a shaft. When I am talking about the shaft, it is a splined shaft. Splined shaft. What do you mean by splined shaft here? Now try to understand, the shaft will be, instead of a keyway, usually the shaft will have keyway. Here instead of keyway, the shaft will be having splines. Now if I have a shaft, the shaft will be having splines here. Okay, so this shaft which I am going to use, this is called as splined shaft. This shaft is called as splined shaft. This is also obviously, this is a part of the clutch. So this is what exactly we are trying to design it. Let me once again continue with this. Now what are the different notations guys? What are the different notations which you see? Try to understand this part, these notations. If you can understand this, we can easily go to the next level. Okay, now here to do this design, basically what we need power. First one, we need power, capital N. Always power will be given by capital N, and small n is nothing but the speed in RPM. Try to see the notations guys. Small n. Torque, see, only we are trying to find D1 and D2, but to find this D1 and D2 you have so many things which you need to make use of. So you have something called as torque. How much is the torque to be applied? What is the torque to be applied? Now D is the diameter of the shaft, which is very much important. Since there is a keyway, obviously there will be keyway factor which we are going to use. The keyway factor which we are going to use. Now this keyway factor which we are trying to talk about is, this keyway factor is because of splines guys. Is of splines. Now this splines keyway factor usually we assume it as 0.75. Okay, I'll anyhow talk about this little while. Now there will be shear stress. Try to understand this. It is purely due to, since the shaft, what kind of stress is shaft is subjected, because it is rotating by default. You need to understand that it is a shear stress which is applied. Okay, now shear stress is applied. Now axial load, we are pressing the lever, so we need something called as axial load. Axial load is nothing but low axial load required for engaging and disengagement of the clutch, for engaging the clutch as well as disengagement of clutch. Now when I say pressure applied or pressure generated due to the applied load, you need to understand this. Pressure, from where pressure is coming, try to understand once again. The flywheel is applying the pressure from the other side. So when I apply a load from here, F I am applying here, so from the other side, flywheel is applying the pressure. Try to understand this part. Flywheel is applying the pressure from the other side. So once again, pressure up due to applied load. Applied load, we are applying the load through a lever or hydraulic force. Now flywheel is applying the pressure from the other side. Now this one D1. D1 is nothing but inner diameter of friction lining, and D2 is nothing but outer diameter of the friction lining. Outer diameter of the friction lining. I'll talk about this DM little bit later after these two notations. So mu is coefficient of friction and I is the number of frictional surfaces. So how many surfaces is effective with friction? So some clutch plates will be having friction lining only on one side because other side is not required. But some faces has both the sides. So obviously here what happens, basically on this there will be a flywheel and there will be a frictional surface. On the flywheel itself, see on the flywheel itself they will attach one frictional lining. On the flywheel there will be frictional lining. Usually flywheel is made of steel, so there will be frictional lining. Then onto the frictional lining there will be one more plate here. There will be a frictional. So this will be the clutch now. This is our frictional plate. So already the frictional lining will be there. So this will be a frictional plate. Now once again there will be a pressure plate at the back side. There will be a pressure plate. So here once again mu is the coefficient of friction and I is the number of frictional surfaces. Now what is this DM here doing? Try to understand now. Now carefully understand here. Mean diameter where frictional forces will act. What do you mean by frictional forces? Try to understand this. This F I call it as frictional force. See the diagram carefully. The F is called as frictional force. Okay. Now what this frictional force is trying to do? Sorry. Yeah. This FF is called as frictional force now. Now when, let me say for example, it is rotating in this direction. It is rotating in this direction. So the frictional force will be always normal to the applied load. Means it is really perpendicular on the frictional plate. So the frictional force will be acting on this. Try to see this. In this direction always the frictional force will be acting in a direction tangential to this diameter. So this is the frictional force. Can you see this? Now the point is where the frictional force will be acting. I call this as mean diameter. From here to here, this diameter is called as mean diameter. The mean diameter means usually what happens is the frictional force will not act continuously on the entire plate. Instead it will be acting at a particular point. Okay, now this frictional force which will be normal to the applied load. So here this is the applied load FA. If you see, observe, this is FA. So but frictional force will be acting here. This will be FF. This will be FF. So once again FA will be acting. FA is called as normal load and FF is called as frictional load. We know that no, obviously, or we can say that mu is we have FF is equal to mu into FA. We could have remembered this equation. So this is what exactly I'm trying to talk about. So the point, the diameter where this frictional forces will be acting is called as DM. Okay, so DM from here, from the center, where exactly it is happening. So once again guys, I tell the notations. We have something called as D1, D2, DM. These are the three diameters, and you have got H. We have FA, and your FF we don't use it. Frictional force we will not find it, but we'll try to find. If you want to find the frictional force also, it is simple. I multiply mu, coefficient of friction, with FA. I can find how much is the friction force acting. But the location where it is acting is given by DM. The location where frictional force is acting is given by dm here. So other notations as usual: power, speed, torque, diameter of the shaft. This is what exactly we'll be trying to find it. Okay, now this is what we have got the notations. So let me write it for you. So what are the different notations before we go with this? And the design is very simple, guys. You don't have to break your heads also. So here I'm trying to talk about notations. Okay, what are the different notations which we are going to use, and try to parallel write with me. So you have capital N. Capital N is nothing but the power in kilowatts. You have small n. Small n is the speed in RPM. You have small n will be the speed in RPM. You have torque, MT. So MT is nothing but torque in Newton mm. So what is the relation between these three? I don't want you to use data handbook to find the relation between these three. Remember the equation. MT is equal to 9.55 into 10 power of 6 capital N by small n. This is the equation which you are going to use. So you are going to use this equation to find the torque. Now this equation can be used in many ways. I can see from this equation I can find the torque, or sometimes he'll give the speed and he'll ask you to calculate the power. So anything I can find from this equation. Yes, and what is the power transmitted by the clutch? I can use capital N. The ultimate outcome will be the power here. And you can ask how much speed this clutch is rotated. So obviously it's rotating. I can find small n also. So this equation can be used in many ways. I can use this equation in different ways. Okay, so this is the basic thing which you need to have. Now let us continue with our this one. So what else other notations we have? Now I have the other notations like towers. Okay, now towers is nothing but the shear stress. Towers is a shear stress in Newton per mm square or MPa, Newton per mm square, or we call it as megapascals. Now how do I make use of shear stress? Shear stress where? You need to understand shear stress in the shaft. Try to understand shear stress in the shaft. Okay, it is not on the clutch. Usually when I say, since you are designing clutch, when I ask a student, that fellow says, sir, shear stress in the clutch. It is not on the clutch, it is on the shaft. Shear stress on the shaft. Now this shaft has keyways. The shaft has keyways. This keyways will be in the form of splines. Okay, the keyways will be in the form of splines. Since they are in the form of splines, I will be using something called as keyway factor. Keyway factor. This keyway factor will be eta. The keyway factor will be eta. Usually this value eta will be taking as 0.75 value. If he is not given, the value of eta will be trying to take it as 0.75. Now how do I use this equation? See, I have already shown how exactly this equation can be used. Now how do I use this equation? Remember guys, what is a shear stress formula? Shear stress formula, I have a shear stress formula. If, can anyone tell me what is the shear stress formula? Towers is equal to?
Force by area.
Force by area. Force by area if it is direct shear stress. If it is torsional shear stress. Torsional shear stress. It is torsional shear stress now. It is rotating.
Torsion equation.
Torsion equation. So I use this equation. Tau s is equal to mt by z0 guys. And see, Krishna sir would have told some other equation for you, but I basically follow this equation, mt by z0. Now what is mt here? Torque. This came from torsion equation. And what is z0 guys? Anyone? Z0 is?
Number of
No, polar sectional modulus. You remember this? I by j, or obviously we call it j by c. You remember this?
Yes.
J by c, yes or no?
Yes.
Usually, also in your class, this equation would have been told mt c by j or mt r by j, yes or no? So remember this from in my class. Now what we will be trying to do is, the formula is mt by z0 is. To find the shear stress, the formula is mt by z0. So mt is the torque divided by z0. Or usually, see, let me write, if it is bending stress, sigma b, I would have told in the class mb by z. So this is the value of sigma b which I'll write. So tau also mt by z0. Now the question comes, what is tau s? Tau s is shear stress, mt is the torque, and polar section modulus is j by c. So for the shaft, what is the value of Z naught? Any idea? Or this equation, since QA factor is there, I'll use the equation eta. Eta tau s is equal to mt by Z naught. Eta tau s is equal to mt by Z naught. Now in this case, Z naught is equal to pi d cube by 16 for solid shaft. For solid shaft, the polar section modulus is nothing but pi d cube by 16. Obviously here the other formula I'll tell you how I got this pi d cube by 16. J is equal to pi d power 4 by 32. C is equal to obviously d by 2, that is radius. So once again J by C is equal to Z naught pi d power 4 by 32 divided by d by 2. So 2 times 16 obviously cube, I got the equation pi d cube by 16. So obviously I am going to use this equation. So how exactly the second equation we are going to use it? This is how I am going to use the second equation. See? So once again, capital N I know, small n I know, it will help me to find mt. Next, tau s I know, So once again, I'll find obviously if shear stress is not given, I can use it. Now I can use this equation. Where do I use this equation, guys? So I will once again write this equation eta tau s is equal to mt divided by pi d cube by 16. Why do I use this equation? I use this equation to find dia of the shaft. I can use this equation to find the diameter of the shaft D, because QA factor I am assuming tau s as 0.75. I mean eta. Tau s is from the material. Mt I have already determined from the previous equation. So what else is left? It is diameter. If you want to find the diameter of the shaft, use this equation. Once again, dear friends, I am not telling you to depend on the data handbook directly. First, be independent of data handbook. Some equations which are very much required, I'll tell you. But basic equations, I don't want you to depend on the data handbook. So two equations which we have learned. One is called as mt and one is called as tau s. Mt is used to find the torque and tau s is used to find the diameter of the shaft. Now still we will go ahead. What are the different equations which are required? Now other than this, what else we need in this particular equations? One is FA. What is FA? The applied load in newtons. The load which we are going to apply in newtons. Because of FA, there will be a pressure. Pressure from where? From flywheel. Pressure from flywheel. Okay, so once again there will be a pressure from the flywheel in terms of megapascals or Newton per mm square. Megapascals or Newton per mm square. And very much important thing is which you need is coefficient of friction mu. Coefficient of friction is very much important. We call this COF, coefficient of friction. Okay, you can make use of table number 19.7 to find the coefficient of friction. So this entire chapter is chapter number 19, guys. In the data handbook, it is volume 1 data handbook, chapter number 19, which I am going to use. So here coefficient of friction for a type of frictional material, I can find it from table number 19.7. So once again, when I show the table, you can understand this. So mu will get it. So here there is one more factor I, number of active pairs, we call it as number of active pairs or frictional plates, all the things. I'll try to explain it. This is not an issue with that. So mu I you have done. Then what else you need? You have D1, you know the internal diameter. You have D2, external diameter. You have DM, the diameter. What is this mean diameter? Most important. Most of the people do not know what this DM. They remember this as a formula, but DM is not this. DM is the location where frictional force is acting, and this frictional force will be always perpendicular to FA. The frictional force will be always perpendicular to FA. Okay, you remember this formula, F is equal to mu into Rn, if you remember this. Okay, now do you know one thing? This is frictional force and this Rn is nothing but I am calling as FA. So once again the formula is Ff is equal to mu into Fa. This is the formula. We don't use to find mu ff here, but you need to understand this. Frictional force will be always perpendicular. Okay, frictional force will be always perpendicular. So once again, if I have a plate here, if you are applying a force in this direction F A, so here the frictional force will be acting in the other direction. This tangentially to this will be F. This will be F. So this is the other notations which we'll be using. So any doubts in the notations, guys? Any questions which you want me to explain during the notations? Anything? Is it clear with the notations? Sunil, come on,
yes,
understood?
Yes, sir, understood.
Can you tell me the formula of torque? Sunil, formula of torque right now. I have just explained how do I find the torque when power as well as speed is given. And guys, I want you to note down whatever I teach. Sunil, last chance, else I'll be forcing you to remove you there. Vinith.
Yes, sir.
Formula of torque. Formula of torque. Sanjay Patel.
Yes, sir.
What is the formula of torque?
So 9.55 into 10 power 6 into capital N by small n. Power by 6.
See, I can clearly understand that Sunil and Vinith, they are listening as if it is kind of a movie. I don't want you to do this, guys. I want you to write it. If you write it, you could have seen your notes and you would have told me. So 9.55 into 10 power of 6 capital N by small n. This is the equation for torque. This is the equation for torque. So once again, this is the equation which I have already explained here in the previous slide. So this is the equation which I am trying to talk about. MT is equal to 9.55 into 10 power of 6 on the top. You can see this. Now, when capital N's power has been given and small n has been given, we can do this. So let me note your numbers, guys. Sunil 19 ME 410, sorry, 19 ME 410, and Vinith 18 ME. All right. So once again, guys, this is what exactly the equations. So let me go ahead with this design. So most important, try to understand this concept. There are two conditions which always happens in the system. One is called as, this clutch plate can be designed in two types. One is, we call this as uniform pressure condition. The first condition is uniform pressure condition, and the second condition is called as uniform wear condition. Second is uniform wear, and first one is called as uniform pressure condition. If you can understand this, obviously now next stages we can go for the equations. Okay. Now what does it mean by this? First of all, see this. Pressure is when I apply the force from our side. The pressure is from the flywheel. The pressure is applied from the flywheel on the other side of the friction plate. Okay, this is the thickness H. Now, how this pressure is applied and why do I call this as uniform pressure is what we need to understand. Now, try to understand, guys. If I am trying to purchase a new clutch, if I purchase a new clutch, the entire clutch will have the same surface. It means the surface will be always flat. Yes or no? So when I purchase a new clutch, if you are purchasing any new component, the surface will be almost extremely flat. If the surface is extremely flat, I can apply the pressure uniformly throughout the surface. Now try to see this diagram. Okay, try to understand here now. Let me say, for example, I have a very flat surface. I have a flat surface. Assume that it is extremely flat. So I have this very flat surface. Now this is a clutch surface. Can be observed. This is a clutch surface. Since it is very much new, obviously I can apply the force. very much new. I can, if I am applying the force FA here, from the other end there is a pressure. Pressure can be applied uniformly here. The pressure can be applied uniformly. This is what exactly happens in this case. This is what exactly happens in this case. So you are applying FA, so pressure is applied. Pressure is applied. Now, what if the surface is not uniform? Try to understand. After some days, since I have started using my vehicle, okay, this is a new vehicle or newly I have replaced the clutch. It was a new clutch. After 1 month, what would have happened to the surface? Now try to see this. The surface will not be flat. It will not be straight, something like this. Instead, it will be something like this. See? Slightly, it will be a worn surface. Okay. Now, can you tell me? Can I apply? Do you think this flywheel can apply uniform pressure now? Do you think the flywheel can apply uniform pressure throughout the surface? Yes or no?
No, sir.
No, sir.
Okay. Now, what exactly happens here? Since the face is very much flat, initially for a new clutch, obviously I can apply the uniform pressure. For a new clutch, always I can apply the uniform pressure. But for the clutch which is already used, the surface would have been worn out. This is worn out surface is there. The surface is already worn out. I cannot apply uniform pressure. So what happens is this condition, I call this as uniform wear. This condition we call it as uniform wear condition. Now what exactly happens in this uniform wear? The frictional force, the pressure will be maximum at the inner radius. The pressure will be maximum at the inner radius. This will be P maximum. The pressure applied by the flywheel will be maximum at inner radius and it will be less of the outer radius. So this will be the pressure which is applied. This will be less at the outer radius. Same thing will happen. So the pressure applied in case of uniform wear condition, this is P minimum. In case of, okay, once again I write it in the other shade. So once again guys, I'll try to explain these conditions. Two conditions most important which you need to understand. There are two conditions which always happens here. One is called as uniform pressure. Okay, I call this as uniform pressure condition. When do I use? It is used when we have purchased a new clutch plate. Okay, when we have purchased a very much new clutch plate. So why it is called as uniform pressure? Since the surface of the clutch will be flat. Is flat. Since the surface of the clutch is flat, now what happens? This flywheel applies uniform pressure. The flywheel will apply uniform pressure on this flat surface. So here I have a flat surface, I have a clutch. So here this is the hole where exactly. Now I can apply the uniform pressure here. This is called as uniform pressure condition. Okay. Now there is one more condition. You have something called as uniform wear. So means uniform wear rate. The entire wear rate is happening uniformly. This is not for new clutches, used clutches. For used clutches. This we use it for used clutches. What does it mean used clutches in this case? Means surface is
Uneven.
or not uniform. Okay. Now because it is getting used, this will be the surface. Now unfortunately, if the flywheel comes and pushes it, what happens? The surface will not be flat. Since the surface is not flat, I cannot apply uniform pressure at all. So in such cases, okay, what exactly happens? I can apply. This will be in this condition. Okay. In this condition, the maximum pressure will be at the internal radius. Keep that in mind. This is one of the famous gate question, guys. Where will be the maximum pressure? The P maximum will be at internal radius. P maximum, I call it as. Always the maximum pressure will be the internal radius. Minimum pressure will be the external radius. This is how it happens. Okay, here also same thing. This is what exactly happens with this. Okay, so this will be a uniform wear condition. So you have two conditions, guys, and if nothing has been given in the question examination in the problem, this is the default condition. This is the default condition. We always assume that there is a uniform wear. The clutch is not a brand new clutch. It is already used. But if they say exclusively it is a new clutch plate or assume uniform pressure condition, then we go for uniform pressure conditions. Else the equations will change in these conditions, guys. The equations will change in both the conditions. So here what exactly happens? In this case, it is only by default I will be trying to take uniform wear condition. We will be considering uniform wear condition. So this is the two conditions which you need to understand. One is called as uniform pressure condition, where the pressure applied by the flywheel on the clutch plate will be uniform here throughout the surface. It will be uniform. But in this case, it will not be uniform. The maximum will be at the internal radius. The maximum will be at internal radius here, and minimum will be at the external radius. Okay, so the outside, the external total external diameter, it will be minimum. At D1 it will be maximum. At D1 it will be maximum. See, you can try to see the surface. This is a new one. This is a new one. Now the second one, if you see, can you see this wear tracks? There will be wear tracks. What exactly is whenever there is a wear track, the entire friction plate will become non-uniform. The same thing, same diagram, it will become non-uniform. What happens in such cases? I cannot go for any more uniform pressure, then I go for uniform wear. Okay, this is what exactly we try to go for this. So now once you have understood your concept, how do I solve the equations? What are the different equations we have? Now I'm trying to go for this equations based. What are the different equations we have and how exactly we are going to solve the numericals? Solving the numericals is quite easy. You don't have to, I said no, it is you should know the art of copying from dead hand. That's it. So let me start with this equation part. These are the equations which we have. I have clearly shown the equations, guys. What are the different equations you have? First one is the torque. So what exactly you are going to find in this case? You will be finding empty. You will be finding empty from this equation. What is the equation you are going to use? 9.55 into 10 power of 6 multiplied by capital N by small n. Second one is the shear stress equation. Now this equation is also there in the data book, but I don't want you to by heart this. I don't want you to remember copy from the data book. The formula is tau s is equal to mt by z naught. Since QA factor I am using it, I have the equation eta into tau s is equal to mt by z naught. Eta into tau s is equal to mt by z naught, where z naught is pi dq by 16. What exactly you are going to find from this equation? You are going to find d. You are going to find d from this equation. You are going to find d. Now next one is mean diameter, dm. What is the mean diameter? Once again, I repeat, the diameter or the location where the frictional force is acting. This has two different. At uniform pressure condition, the mean diameter formula is given by this. Okay. Now in uniform wear condition, this is the uniform diameter. So from where exactly, don't waste your time in by-hearting these equations. You use the equation number 19.85a and 85b from the data handbook. So you have the equations, okay, 19.85a and 19.85b from the data handbook. So you have these two equations, 85a and 19.85b. We use this. Once you have got this, so one of the equation you will use to find mean diameter dm. You will be finding mean diameter dm. Then once you have found this, then axial force. How much axial force we need to apply to disengage the clutch? Or during the engagement, how much axial force is already applied? This is what exactly axial force. So once again, it has two equations. One is for uniform pressure condition. It is given by the equation 19.86b. 19.86b, you have the equation. For uniform wear condition, you have the equation 19.83. You have this equation 19.83 for FA. Once you have found this, the torque transmitted by the clutch, there is one more equation. The torque transmitted by the clutch is given by the equation number 19.84. So you have the equation 19.84, the torque transmitted by the clutch. So these are the only equations which you are going to use to find dimensions of single plate clutch. So you have this equation. Okay, so once you are done, obviously 30% of your chapter is over. I see, if I would have started this as a first class, by this time this clutches would have been over. Nothing is there to teach in clutch. So here This is a single plate clutch which I am trying to talk about. So once again come back, let us once again discuss this equations. So what is the design? What is the design procedure, guys? Step number 1, you will be finding torque empty. You use the equation 9.55 into 10 power of 6 multiplied by capital N by small n. We will find this torque. Okay. Now here this torque will be in Newton mm. Always remember the torque you will get in Newton mm. The power is substituted in kilowatts and the speed is substituted in RPM. So you have your first equation. Your second equation, what do you have in this second equation? You have shear stress. The formula eta tau s is equal to mt by z naught. Okay, and this z naught is given by pi d cube by 16. What you are going to find from this equation? You will be finding diameter. Diameter of what? Diameter of the shaft. This is eta. Okay, which we will be finding. Diameter of the shaft. This is your second equation. Once you have got second equation, the third equation is mean diameter. Mean diameter. We call this dm. Now we have two conditions, guys. One is uniform pressure condition. The equation is given by 19.85a. So the equation is given by 19.85a. This is what you need to remember this. Now there is something called as uniform wear condition. The equation is given by 19.85b. That's it. What you are going to find in this case? dm. The fourth one, you will be finding axial pressure. Sorry, axial force applied. FA. Axial force. How much is the axial force which we are going to apply? Now once again here also this we have two conditions. Uniform pressure condition. The equation is given by 19.86b. The equation is given by 19.86b and uniform wear condition 19.83. These are the two things where exactly you'll be using. You'll be finding FA. So one of the condition which you will be using. Any very few problems they'll ask, try to find in both the cases. Now last one is the torque. Once again the torque. See, the first equation and the last equation is almost the same, but the first equation is from the shaft how much is the torque transmitted. Now means from the camshaft to the flywheel, from the flywheel to the hub of the clutch, how much is the torque transmitted. Now this clutch, how much it is transmitting this torque to the this shaft, obviously. How much is the torque transmitted to the transmission system? We assume that 100% of the torque, whatever it is generated at first one, because of the power, the same torque has to be generated by the torque, by the clutch. But practically the first value of MT and fifth value of MT will not be the same. But this is one of the assumptions which we will be trying to take in this design. We assume that the value of equation, whatever the value obtained in equation number 1 and the value of, which we are going to use in equation number 5 are the same. So we use this equation MT torque transmitted. This torque transmitted we are going to use the equation number 19.84 from the data. Okay, so here these are the equations. Now in this case, FA, you know what is FA? FA is nothing but axial force. From here we get it. dm from the previous step. I is the number of frictional pairs, and mu is what exactly we are going to use it. Is it clear? Coefficient of friction. Any questions still now? Any questions?
No, sir.
Right. So the design is very simple, guys. I'm trying to design of disc plate or single plate, and we call this a disc clutch or single plate clutch. That's it. This is your design. Now, what are the things which you need to know? There are still some more equations. I'll be trying to talk about these equations when it comes to the numericals there. Okay. Now, what exactly you need to know? Sometimes, what happens? The shaft material tau s value would not be given. This tau s value will not be given. Why do I need this tau s equation here? Tau s is used to find the diameter. Now this fellow will not give this tau s equation. If you don't give, what should I do? Assume the shaft is made of carbon steel C40. Assume that the shaft is made of C40 steel, having a yield stress of 328 megapascals with a factor of safety of 3. with a factor of safety of 3. Once you have assumed this, then what we do is sigma is equal to the normal stress, the design stress will be equal to 328.6 by 3. I'll be getting the value of 109.53 megapascals. So I get the value of sigma. Then tau is always 0.5 times of sigma. So I'll get 0.5 multiplied by 109.53. I'll end up in 54.76 megapascals. This 54.76 is nothing but your towers. So whenever he has not given towers, assume that you need to write clearly this in the external examination. Assuming the material of the shaft as C40 steel. So you assume this material and you'll be writing this. Now, if keyway factor is not given, assume that it is 0.75. Assume that it is 0.75. And if speed is not given, take the speed as 1000 rpm. Very rarely it happens, but if he is not given, anyway, you take this. Now, sometimes what happens, he'll not give one speed, he'll give 3-4 speeds. N1, N2, or it says that the speed is varied from 1000 rpm to 2500 rpm. Which speed should I select? Always remember this, guys. We design for maximum torque. Now we know this power, and N is always inversely proportional to torque. Which exactly we do is, so maximum torque is obtained at minimum speed. We will be trying to take this N1 here. Okay, so sorry, not capital N, small n I'm trying to talk about. Small n is always inversely proportional to torque. Can you see this small n? I'm trying to talk about the small n is always inversely proportional to torque. So once again, small n, the speed is always inversely proportional to torque. So if you want maximum torque, take smaller speeds. So always, now he'll give the range of speeds 1000 to 2500 rpm, or it says, this fellow says it is rotating at 1000 rpm, 2500 rpm, 5000 rpm. Determine the formula. So entire area will be trying to select the minimum speed. Always will be trying to design for minimum speed. So that why minimum speed? There is a reason. At minimum speeds, I will be getting maximum torque. So for minimum speeds, because clutch is designed to withstand the maximum torque. So this is what exactly. Now the question comes, sometimes the material, I said no, frictional plate. What kind of frictional material are we going to use? Because based on the frictional material, we'll be selecting the value of mu. What is mu? The coefficient of friction. Okay. And how do I select the frictional material? We'll be using the table 19.7. We'll be using the table 19.7 to select the frictional material. Now see this, guys. See this table. This is the table number 19.7. Frictional materials to be used for clutches. So here, now what does it mean? What is varying and what is opposing? Try to understand. This varying is nothing but on the clutch plate. The opposing material is the flywheel material. Guys. Try to understand this. So this is flywheel. Okay. This is the opposing material. So what exactly it means? So cast iron or steel is usually the flywheel material, and this is your clutch. So the friction coefficient of friction is between clutch plate. This is the clutch plate, and this is flywheel. So clutch plate between flywheel. So if the clutch plate is made of cast iron bronze and the flywheel is made of friction material is made of cast bronze and the flywheel is made of cast iron or cast steel, what is the friction? There is two frictions. One is called as wet friction and one is called as dry friction, guys. Usually what happens is this is the value of mu. Okay. Now we don't take wet friction at all because we don't do lubrication for clutches. We don't take wet friction. Instead, we'll be trying to take dry friction. Okay. So this is the dry friction which I'm going to take. This is the values. So all these values, whatever it is shown here, the dry friction values which we are going to take. Okay. If the material is not given anything, let me say for example, the material itself is not given. By default, I assume that the material is made of leather. The friction material is made of leather and the flywheel is made of by default cast iron or steel. So I'll be trying to take the value of 0.3 to 0.5. The average is 0.4. I'll be taking the value of mu as 0.4 now. The value of mu is 0.4. Sometimes the fellow will not give the pressure. So once again, maximum pressure I'll take here. Can you see here? This is the maximum pressure, the flywheel which will be applying. So 0.0686 megapascals to 0.746 megapascals. Now here, this is what exactly the maximum pressure I'll be trying to consider, and I'll take the average value. Now try to understand, guys, this is how the table to be seen. Sometimes he says asbestos. So many types of asbestos is there, but we'll be taking molded asbestos. Molded asbestos value which we'll be trying to take. Now this is for your video point of view, how to select the data from data handler. But try to understand what are the different materials for flywheel. This is a question which I'll be asked for in a knowledge point of view. You can see this different materials which can be used for the flywheel. See, I can use cast iron, I can use steel, I can use chromium plated hard steel. Okay, this is the materials used. Can you see any other things? You don't have. Either you use steel, iron. This is the only two materials where clutch press can be used. Now, where the friction lining, see, I can use bronze. I can use iron also as a friction lining, because iron also has good coefficient of friction. I can use steel. I can use phosphor bronze. Okay, I can use wood. We can use wood, leather, cork, felt, vulcanized fiber or rubber, asbestos. This graphite. Okay, phenolic resins. These are the different clutch plate materials. And most important, guys, once again for knowledge point of view, I'm clearly talking about it. This is what exactly you need to study. Unfortunately, we fail. You never study this part, because lecturers, as a lecturer, we will say that as in the textbooks, they concentrate on this area. But obviously you study to fail. When should I use this clutch? Okay, what is the advantages? See, this clutch is relatively very low cost. Okay, now this is where exactly I can use it. Now see, the one, if I am using phosphor bronze, what is the advantage? Very high cost, but good wearing qualities. See, it is the advantages. Certain comments he has given. I want you to spend some time to understand this. Any of this, while solving the problems, you understand this, but spend some time to understand. This is where the knowledge point of view comes into picture. So this is how exactly the frictional materials for clutches will be selected. Any questions, guys?